Hey guys, welcome back. Today we're going to be talking about switches. Let me get this wire out of here so it doesn't interrupt me. There you go. Alright, you might be thinking of switches as something like this, a little button. Or possibly, if I can find it. Uh-oh. Ah, here it is. A little single pole double throw, meaning there's two notes. Yeah, or I don't remember. I'm gonna have to research that again. I believe this is actually single pole double throw, meaning it's one line and it has two possible outcomes. So what it does is interacts these two together when this piece is over here, and interacts these two pins when this side is over here. Also, you could get it in the center, I believe. No, you can't. Okay, there's other switches like that. You could get them in the center and disable all of them. But this is a simple kind of switch. I wanted to show you guys something a little bit more cool. So these are many switches you're gonna come across per se. This normally open switch. There's also a normally closed, but I have a normally open. And this is basically how it looks. And this is how it kind of looks if you were to put it in a explanatory sense. It shows that these two guys are interlinked and the two guys up top are interlinked. So when you push down the button, there's a little pole that jumps across these two, creating a contact. Now I could show you that if you guys give me a few seconds to connect up the wires. Or 400 milliamps. If I can find it here in my tweezers. So this little thing is our little button. These are the two contact pins, and when you push down, you create a contact. If I can press the thing. Come on. Alright. That's what happens. And normally open means it's without any physical interaction with the button. It's open. It creates an open in the circuit. And normally closed means it's automatically closed like this until the user pushes down. How the normally closed buttons are formed is they actually just reverse it. They just put these two guys on the inside. So do something like this, and they have a spring. Oh my god, give me a second, guys. Probably should have done the normally closed circuit too, but now I just thought of probably should do both. So, and there you go. This is our normally open circuit, and there's a spring in there, imaginary spring here, and then when you push it, it disconnects the circuit, and when you let go, it connects the circuit back. And that's your switches. Simple as that. Moving over to NPN or PNP, which are BJTs, bipolar junction transistor. Bipolar meaning two polarities, negative, positive, negative, positive, negative, positive. There's two varieties of BJTs. I believe I showed this in one of my schematic videos explaining them, but pretty much the main difference between them is that the base of them is different. So it's controlled by a negative or it's controlled by a positive, and that's pretty much it. I mean, and they have some different applications depending on whether you're in need of a different polarity on a different piece of a circuit. So there isn't big of a difference between them, between just the polarities being switched up. And how they work is, think of a floodgate. I cannot draw this because I suck at drawing. You could tell. Alrighty guys, I finished up the circuit, and this is what a BJT does. This is actually, I'm using a S8050. The only difference between the 222 and this guy is he can take up to 25 volts compared to the 2222, which is 40 volts, but it can handle up to 1.5 amps compared to the 2222, which can handle up to 6.6 amps. So I'm going to be using this guy, and shit, I forgot to put a resistor across this thing. Give me a second. Alrighty, put the resistor in to protect the LED, and this is what it does. So this is, I believe, 100K potentiometer. I have nothing lower, so yeah. And it's pretty much an amplifier circuit. And the more I turn, the brighter it gets. And I just burnt out the LED a little bit, but yeah. So you can see it's brighter, dimmer. And the thing is, how this guy is, what you guys will see in the after this video, after this clip, is that these guys are somewhat similar to relays because they use small current to control a larger current. So the base is less current, is the little bit of current that's controlling the bigger current in the emitter and collector. A relay is pretty much a little box that uses an inductor to control a switch. So this is a complex version of it. It's not exactly what it looks like, but pretty much how this works. It has 5 pins. It's this one. Some have yeah, I think it's 5 pins and then 3 pins. No, 4 pins and 5 pins. What that one extra pin does is it adds another possible output or path technically. So this is the simple version, and on a relay it has 5 things. So here, let me use my, we got this one right here and this one right here, you see, is the inductor, is the magnet, that's electromagnet. This right here is this is our center point. This is our I forgot, this is just main line. All right, this one, oh god, sorry guys, I need to see it. So this one right here is one path. Oops. And the other one is another path. So since there's two possible outcomes, this one or this one of them is normally closed and one of them is normally open. That means this one and this one, I think it's this one, or this one and this one, is automatically connected, and when current is fed through these 2 pins, it will change. It'll enable the magnet, and then switch the contact to this one, leaving this one open, this one closed, and then creating a contact between these 2. So that's pretty much how a relay works. That's garbage version, but I wanted to show that this is the magnetic point piece. When this is energized, it'll cause this to move this switch over here. It's a horrible drawing. This is a simple version. And here is an example. It's a good one, actually. Let me wire them up, connect them. Alright. And what relays are used for is using small amount of current to control a larger current. So we got our 9 volt right here. That, let's just say this is our high current, which is, I don't know, what some relays have specs on them. Some have data sheets that tell you, and this says it's able to transfer 10 amps, 250 VAC, or 10 amps and 30 VDC. So we're good. but pretty much 10 amps is max. So let's just say this is our 10 amp 25 volt DC supply, and our LED is I don't know, something that's needed to be powered on. This is just a simple explanation. And our power supply, this pin, this one right here, and this one right here, is the little current that controls this magnet. And when it's enabled, I don't have a very good thing, but pretty much when it's enabled, it creates a magnetic field pulling the pin down. And it stays up because I don't have a perfectly normal thing, but if I do really want to make it a little bit better, I could pull it away. And I should do it. Oh. Made it even more springy, guys. Oh man. Whoops. There you go. Oh. Pretty much, I hope you guys get this. So pretty much when small current is fed to this coil right here, it's gonna create a magnetic field that's gonna pull it in. For some reason it's pushing it away. I don't know why. It might be the spring. But pretty much that's how it works. So let's bring it closer. Let's push this over here. It's creating sparks because we're using like 1.6 amps. There you go. Yeah, it's pretty much how a relay works. 2 wires or 2 pins right here. 2 pins right here are energized, causing the switch over here to the contact to switch to this side, or the other way in reverse. And yeah, that's it. Hope you guys enjoyed this video. Hope you learned something. And yeah, see you guys in the next one.